change. But to look into it closely, a derivative is the rate of change of one quantity in terms of another. So how could we see derivatives in our everyday life or in our surroundings? Well, practically we could use or incorporate derivatives in, say for example, business or in monitoring our finances. And if you want to know how things change over time, derivatives could be a big help. So for example, you may want to know how, or you may want to test how fast the water in the Angat Dam rises. You may want to solve for the rate of change in its water level. Also, without derivatives, there would be lesser technological advances, since without derivatives, scientists would have had a harder time in doing, say, physics or chemistry and the like. So with these examples, we prove that derivatives are indeed essential and significant in our lives, therefore making it as well substantial and important to actually study about. But of course, in studying derivatives, you need to know a thing or two about algebra or trigonometry, because without these, it is guaranteed that you would have a hard time in understanding basic concepts such as how is the square root of x equivalent to x raised to 1/2, stuff like that. So that is why you really need to know about derivatives. So for this performance task, the assigned problem to me is problem number 5, which says all edges of a cube are expanding at a rate of 3 centimeters per second. Determine how fast the surface area is changing when each edge is A, 1 centimeter and B, 10 centimeters. Hi, so this is my performance task in calculus entitled My Calculus Vid. I am going to be presenting a tutorial on the application of derivatives. And the problem assigned to me deals with surface area. Okay, so to start with, my problem is a relative trace problem dealing with a cube. So to solve this problem, we first draw a cube to help us visualize, and then assign the edges as x. The problem says all edges of a cube are expanding at a rate of 3 centimeters per second. Determine how fast the surface area is changing when each edge is at A, 1 centimeter, and at B, 10 centimeters. Okay, so going back to the cube, x is the edge of the cube, which tells us that dx dt is 3. Therefore, that's our first given. And then the problem asks us to find out how fast the surface area is changing when each edge is at 1 centimeter and 10 centimeters. But first, we have to deal with A. Okay, so let's start with the first problem where x is equal to 1. We let S as the surface area, and we need to find ds dt at the moment when each edge is, of course, 1 centimeter or 10 centimeters respectively. After that, we need the formula for the surface area of a circle, of a cube rather, which is 6x squared, because of course each face measures x squared and there are 6 faces in a cube. Okay, moving on. Next step is to find out the derivative of s with respect to time. And in order to do this, we solve ds dt applying the concept of product rule. We get 12x. So we have ds dt is equal to 12x times dx over t, applying chain rule or implicit differentiation. Then, after that, we could plug in the value of dx dt, which was given. So we have 12x times 3. We have to simplify this part, therefore having 36x. Now all we have to do is to substitute the value of x in 36x to find out how fast the surface area is changing when each edge is at 1 centimeter. So we have 36 times 1, giving us 36 square centimeter per second. So to interpret this, the rate of change of the surface area of the cube is 36 square centimeters per second when its edges measure 1 centimeter. Okay, so moving on to the second part of the problem, where x is 10, where each edge measures 10 centimeters rather. Okay, we are basically just going to repeat the process in solution A, only this time our x would be of course 10 centimeters. Okay, so we then draw another cube. Next. So as you can see, this part right here is the one that changed because our x this time is 10. So we substitute 10 to the value of x, therefore having 360 square centimeters per second. For the interpretation, of course, the rate of change of the surface area of the cube is 360 square centimeters per second when its edges measure 10 centimeters. So that's it. That's how we practically apply the concept of derivatives. So I hope you learned through my example, and thank you for watching.